Between January 7 and 31, 2025, a series of wildfires left a large portion of Southern California in ashes. This was reported as one of the most devastating wildfire events in the state's history. In this video, based on these events, we are going to analyze the before and after conditions of the burned areas using Sentinel-2 imagery. Without further delay, let's jump into the video. Last week I released a video similar to this one in ArcGIS Pro, and today I'm going to apply the same methodology with a small twist at the end. On the screen we can already see the burn area perimeters, and the goal of this video is to analyze two satellite images, specifically from Sentinel-2, on two different days, one before the January 2025 wildfires and another right after. In the top bar under raster, we're going to select the raster calculator option, and the formula we're going to use is the difference between band 8 and band 12 followed by a division by the sum of band 8 and band 12. First, I'm going to click on output layer to choose the location and the name that my result will have. I'm going to name it dNBR, which stands for Normalized Burn Ratio, followed by the date, in this case January. To proceed with creating the formula, I'm going to click this arrow under operators to make the formula field visible, and the expression is as follows. We open parentheses, select band 8 from January 2nd, followed by the subtraction sign, and then select band 12 also from January 2nd. We close with the parentheses, add the division sign, and repeat the same expression, but this time using the addition sign. We click OK and wait for the result. Here we have the first result, and now we're going to do exactly the same, but for the image from February 1st, 2025. So, in other words, this will be band 8 minus band 12 divided by band 8 plus band 12. Close parentheses, click on output layer, and this time the output name I'm going to give is dNBR_February. Click Save and OK. Now that we have the first two results, I'm going to change the color ramp to more intuitive colors, red for the negative dNBR values and green for the positive ones. Let's start with the January image. I'm going to right-click on this layer and select the Properties option, and then Symbology. I will change the render type to single band pseudo-color. I'll click on the color ramp. I will also delete the intermediate classes. Set the color on the far right to green. And the other one will stay red. And now let's do the same, but this time for the February image. Properties, single band pseudo-color, color ramp, delete these values, and change this one to green. And click OK, and OK again. Now let's compare the two images to see the before and after, especially within these perimeters. The result we're looking at right now is from January, in other words, before the wildfires. If we go to our table of contents and uncheck the January image, we can compare the two images. We can see that in the second image, within the perimeters, the color shifts mostly from green to red, which indicates a significant change in the dNBR values. To wrap up and enhance our analysis, we're going to calculate the difference normalized burn ratio, dNBR. This index helps us measure wildfire severity based on the difference between the NBR values before and after the fire events. Once again, we're going to open the raster calculator tool, and the expression is simply the NBR before the fire, January, minus the NBR after the fire, February. Let's save it with the name dNBR 2025, save, and OK. Let's just uncheck the previous images, and here we have the dNBR. I'm going to adjust the colors once again. Move these to single band pseudo color, remove these middle ones. Now the left far will be green and this one will be the red. We click OK. And now we'll get an even better perception of the damage caused by the wildfires. Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.